Talk about 221 maximal square. Given an m times n binary matrix filled with the zeros and ones, and find the largest square contains only ones and return its error. So the metric is 1 0 1 0, like here, right? So we can return largest square. Okay, so for this example, it's like here, and this one is the max, so it's 4. And for here, you can see here is just only 1. Okay, so the problem is give you a matrix and you have to find the maximal square contains all the 1. Okay, let's analyze this first. So these problems, how could we do this? So I want to know the stuff from here, how long I can generate the square, right? So for this way, I didn't know. So if I encounter here, I can see, you can see I already checked previous before, right? I mean, this one I already checked. So which means it's kind of, I at least need to TC time O n times m time to scan all the. Alright, scan from here, and for example, if we take this one, if we scan it, come here. So yeah, we can start from here, right? We can, because this one is already see before, so we can know this is whether it's 1, and how max about this length, right? Then we got this. It's kind of like we will see like current here. For example, we start from here 1, right? So we have the fs like current is ij. It's based on the previous ij minus 1, and also based on the ij, this one, and also this one. So we have the ij. Right, so we have to know current here. Start from here, how many, this how long it is. So here is just 1, and for here you can see this one, it should be 2, and for here you can see 1 2 3 4. So we pick up the minimum one. So this one should be this is current here. This should be 4. This should be kind of like 2, and this one should be 1. So the minimum of this and the plus current here is should be 2, and because this return the square, so we need to return the 2 times 2 is equal to 4. So we find the something. Okay, so we also need like global result to check it. Okay, so these problems we can use the DFS to solve this. Because when we go here, we need looking back, right? So the longest way. Yeah, let's see, write the code here. Right, and for int I equal to 0, smaller than an I plus plus. Okay, so for this one we can use the DFS like ij matrix to check results. We have to write the global results. That's from 0. result and this answer. And after finish, we can return the result times result. Okay, so we can translate this for a tree. So if we start from the ij, we have the 3 branch here. This one or this one or this one. So we have the 3 branch. Need to look in DFS. Okay, so if I is smaller than 0, which means out of boundary, so we don't take it, just return 0. If not, we keep checking, right? So if the matrix ij is equal to 1, then if this is equal to 1, which means current we should plus 1. So return the maximum I minus 1 j matrix. Also, we should have taken the minimum one. Max I j minus 1 matrix. And also we need to plus 1 because we have to calculate current this one. Okay, so this is 1. If not equal to, then we just return like a 0 because not exists. We can check first. See, it works, right? And time exists because this time it will be the TC will be the 3 branch this will be n, and the space should be the O(n) times this, because 3 branch and based on the level here, right? So it will be the worst will be this. So let's see. So we have to use like a memory, which means when we encounter like every time we have over and over to check, right? So if we count here, we have to check, go back for here, and this tree, some here is already if we check in this one, it's already checked before. We already have the result, so we need to memory it. So we have to use the memory to improve some duplicate part. Here. Memory here, yep. So we have to initialize. -1 here, yeah. Memory. So for here, if the memory equal to not equal to -1, which means we already checked before, so we can directly return the result. It's kind of like cut tree. And for here, we need to start this memory. Here. We can check. Oops, okay. oops, oh, equal to 1, equal to 0. Yeah, we can check for this. See, it works. And for the time complexity, we just like kind of like to fill this table. So the time complexity, it will improve to the O(n) times m, and the space also is O(n) times m. This is should be great. Okay, so because this way we also can write into the very common dynamic program. So I will call this like a one-to-one to translate. So what is the translate means? So for here we can write in some normal dynamic way, right? So we kind of like we have the function here and something I plus here based on I j plus equal to something in that way. So let's see how do we do the translation. So for here you can see memory ij is equal to the fi is max minimum I minus 1 and j right. This is previous here f I and j minus 1, and also for here is ij. Yeah, based on this, so we can do something here because I minus 1, but when we follow with stuff from the 0, so we can translate this one plus 1. We can extend the table to plus 1. For here should be move, right? This should be plus 1. Yeah, because we move like this way. Now we can write here. So we don't need this thing now. All we need is the function. But for here we need to table, right? This one is follow the function because we plus 1 here, so this one is also need to plus 1 here. Okay, so we don't need to write this. If the matrix ij equal to 1, we should do the f j plus 1 plus 1 here, and result should be updated. J plus 1. When it's finished, we can, yeah, this is a finish. So let's see. Okay, something happens here is a 1. plus 1. The output, it should be 1 now, so why this right, so character is equal to 1. The same with this function. J plus 1. That's just no problem. Let's see what's the submission before. Not this. Not this. Okay. Oh, I see this way. And this function wrong, not plus 1. The function we translate to run. Yeah, it works. This one translates around here. I need very take care because this should be minus 1, j minus 1. Yeah. Yeah, this time complexity is same. It's O(n) times n, and this one space. This. And thank you.